Welcome back, friends. We are studying the subject manufacturing process. In manufacturing process, we are studying we are studying the topic metal forming, sheet metal forming process, and in sheet metal forming process, we are studying the mechanics of drawing. In the drawing, we will see Fn, Fh, and V is the velocity of the punch. Bending at die and punch radius is given in second figure, and in third figure, straightening the bent sheet stretching is given. Straightening is given in figure 3. In figure 4, Fh is the holding force and F is the punch force. V and F are given, Fh and Fn are given. In figure 4, compression and thickening of the flange is given. And in fifth figure, wall thickness variation is S. Wall thinning maximum at bottom corner of curve maximum is 25%. Figure shows stages in deformation of the work in deep drawing. One is first is punch makes initial contact with work, second is bending, third is straightening, and fourth is friction and compression, and fifth is final cup shape showing effect of thinning in the cup walls. Symbols: V is equal to motion of punch, F is equal to punch force, and Fh is equal to blank holder force. Drawing without blank holder and ironing. Figure shows drawing without a blank holder. 1. Starts of process, end of stroke. Symbols V and F indicate motion and applied force respectively. Figure shows dp minus dp less than 0.5 t, large T0 to dB required. Ironing is given. Figure shows ironing to achieve a more uniform wall thickness in the draw cup. Start of process. During process, note the thinning and elongation of walls. Symbol V and F indicates motion and applied force respectively. Stretch forming. Stretch forming process. Sheet metal is stretched and simultaneously bent to achieve shape change. Jaws are shown in figure. F is the force and V is the velocity of the die. Punch. Stretch forming starts of the process. First is the figure in the figure shows start of process. Second is form die in pressed into work with force F die, causing it to be stretched and bent over the form. F is equal to stretching force. Now force required to in stretch forming. F is equal to LT YF. L into T into YF, where F is the stretching force, L is the length of sheet in direction perpendicular to stretching, T is equal to instantaneous stock thickness, and YF is equal to flow stress of work metal. Die force is equal to F die can be determined by balancing vertical force components. Roll bending. Large metal Sheets and plates are formed into curved sections, usually rolls, plastic deformation, but no significant material flow. 1. How initial straight part of sheet is bent, how cone is rolled. This is the example of the roll bending. Types of spinning. Three types of spinning are given: conventional spinning, shear spinning, and tube spinning. Conventional spinning method. In conventional spinning method, is completed in several passes. Thinning occurs, but not to a great extent. Blank diameter reduces as process proceeds. Thin blanks are used. This is mandrel is shown in figure. Clamp is shown. Roller tool is given. Figure 1 shows conventional spinning. In conventional spinning, the process 1 is set up at start of process, during spinning, second is during spinning, and third is completion of the process. Shear spinning. Deformation is performed through shearing of blank parallel to the rotation axis. Final thickness is reduced extensively. Thick, thick blanks are used. TF is equal to T into sin alpha, where alpha is given, T is given, clamp is given, mandrel is given, roller tool is given. Figure shows shear spinning setup and completion of process. Tube spinning. In the tube spinning is used to produce tube and cylinders. As the roller moves in axial direction, the thickness reduces as and the length increases. The roller touches the parts of the tubular blank. The deformation is local. The figure shows the three figures of mandrel, feed, roller tool. Thus, we have seen the tube spinning operation in this session. We will see the next session, next topic. Thank you.